Okay, so I'm going to work through the calculations here for determining which one's the limiting reactant from our lab. So remember, this is our data that we have. We have the mass of PbNO3 was 0.28 grams. The mass of potassium iodide we use 0.49 grams. Okay, so right, if we have grams, right, our first step is to convert those into moles. So let's see. And go over here. So let's do that first. So PB, I'm gonna go off to the side here. So we got PbNO3 2. So we got to figure out the molar mass of that. Let's see, we got 207 for PB. We got 2 nitrogens, right, when we distribute that. So that's 28. And then we got 6 oxygen. 6 times 16 is 96. Let's see, plus 28 plus 207. Okay, so that's 331 grams, right, in 1 mole of that. And then we also got Ki that we're going to need. That's just 1 potassium, 1 iodine, so that's 39 plus iodine, the big one, yeah, 127. So 266 grams. No, sorry, 166. 66 grams in 1 mole for Ki. Okay. So let's see. So for PB, so 1 mole is 331 grams. So we don't know the moles, but we do know that we used 0.028 grams. Okay, so we're going to have a really small number of moles. This is going to be 0.28 divided by 331. Oh boy. And we get 0.00085 moles. Okay, really small number. Okay. So I'm going to put that in for the before for the PbNO3 Okay, let's do the same thing for Ki. So we had, let's see, 1 mole is 166. We don't know how many moles are in 0.49 grams, but it's going to be more. So let's see, we got 0.49 divided by 166 is 0.0029 moles. No, I'm going to leave that there for a second. So what we do in the limiting reactants, right? Those are our starting amounts, right? More moles of Pb of the lead one than of, more moles of the potassium one than the lead one. Now we want to convert these into PBI, so I'm going to cross out the last column. But we're going to do 2 separate VCA tables. I'm going to cross out that product we don't care about, the liquid, each time. Now, in the first one, I'm going to ignore the Ki. In the second one, I'm going to ignore the other reactant, PbNO3. So we're going to calculate these assuming that we used up all of the lead nitrate in the first one and then all of the Ki in the second one. Okay. So let's see. We know there's none of that PBI to start with. So we're going to assume in the first one here that we're going to use up all of those moles. Okay. Right. And then we're going to create, let's see, we're going to use that number. Right. And then we're going to create our fraction of, let's see, PBIs to PBs. Oh, so perfect. That's 1 to 1. So this value is going to be just 0.00085 moles. So if we used up all the lead nitrate we started with, we'd get 0.00085 moles of lead iodide. Okay, we're going to do the same thing in our second table here, except we're going to assume that we used up all of the Ki. And then in one of these, like, we're just going to like ignore the line to separate those. We're just going to ignore the one that like is the one that becomes the excess. So let's see, we got our value there, and our this time, let's see, oh, we got 2 KIs for every 1 PI. So I gotta divide that by 2. So we'll have 0.00145 moles. Okay, so if you look at this bullet point down here at the bottom now, the reactant that produces the least amount of PbI2 is the limiting reactant. So which one produces less product? Yeah, it is this first value right here, right? We've got an extra 0 placed there. So our limiting reactant, then if we trace this back, is PbNO3, or PbNO3 So we have less of that than the Ki. We have less of, we produce less lead iodide from the starting amounts of that. Right, in the same way as our other lab, right? We had the blue stuff ran out, the blue copper carbonate ran out. So what we're going to do then is this is like what we're going to use for our theoretical yield calculations. This one here, more or less just going to ignore that. So we know that Ki is going to be an excess, right? Ki is excess. This is the one that limits how much product we can make. Okay, right. And then the last step is to convert this theoretical number of moles. We got to convert this into grams, right? So make myself a little space here. So we got 0.000085 moles. Right, we don't know how many grams that is. But we can do 1 mole for, let's see, this is PbI2. I got to find a molar mass for. So that's what, 207, and then 2 times 127 for iodine. All right, so big molar mass. So 127 plus 127 plus 207. That gives me 461 grams in 1. Okay, so when we cross multiply, it looks like it's just going to be that times 0.00085. And then my answer here is 0.39 grams. Okay, 0.39 grams. Right here, this is my final answer. I know it's kind of messy, but this is my final answer here for the amount of grams of PbI we should produce. So grams of PbI in the end should be 0.39, and right, this is the theoretical yield. That would become the theoretical yield right there. Okay, right, and it's going to depend on when we measure out our our filter paper, subtract the filter paper out. How close do we get to that? But that's the amount of should be the most we get when we do our reactions, 0.39.